So we'll be looking at maximum and minimum turning points. And in the previous video, we looked at an example where we were trying to determine or locate the turning points, where we had a function, x cubed over 3 plus x squared minus 3x plus 3. We went and differentiated the function, made that gradient function equal to 0, and found the x values where the turning points occur. So we had x equals -3 or x equals 1. And then we went on to find what those y coordinates were. And we found 12 and 4 over 3. And we found our two turning points were -3, 12 and 1 and 4 over 3, which is represented on this graph over here as well. So what we'll do is now we'll look at how do we provide evidence, or how do we determine which one is a maximum or minimum. And there are really three options you have. You have either graphical evidence, you can do a gradient check, or you can do a second derivative test. And I'll go over all three to show you how we can do that. So obviously this purple function I drew up using the function on OneNote. However, if you were in an exam and you were given those turning points, and I'll write them down again over here, I'll get rid of this over here. So we were given those turning points, -3 and 12 and 1 and 4 over 3. That's what you found. What you could do is in the exam you can draw a set of axes, okay, x and y, and I'll just write the original function over here as well, draw in a different color. F of x equals x cubed over 3 plus x squared minus 3x plus 3. And what you might do is just look at the features of a cubic function. So since this is a positive cubic function, you would have something along the lines of this. And what you could do is you can just use these coordinate points roughly. You might not draw the function exactly how it is. Like every point won't be exactly what it is, but you can roughly determine that, hey, look, this is -3 and this is 1. And you might, if you want to do the y coordinates, you might do the y coordinates as well. 4 over 3, and just say, I mean, this is my max, this is the max, or local maximum, and this is the local min. So just by drawing a rough graph and showing the person that's marking and going, okay, this is what I could do, will show as evidence of the maximum or minimum. So that's showing graphical evidence, and then just drawing a rough graph. The other one we're going to do is a gradient check. So again, we've got our function. We'll write it up. F of x equals x cubed over 3 plus x squared minus 3x plus 3. And what you might do is differentiate that function, which we did before. 3x squared over 3 plus 2x minus 3, when we've got x squared plus 2x minus 3. And now what you want to do is, since you know that the turning points are 3, 12 and 1 and 4 over 3, what you might want to do is choose x values on either side of either point to determine which one is your maximum and minimum. So I might test 2 points over here, so I might test -4 and -2, and over here I might test 0 and 2 to see what kind of gradient do I get. So if I just substitute in -4 for x, I get -4 squared plus 2 times -4 minus 3. We get positive 16 minus 8 minus 3. Therefore, we get 8 minus 3, which is 5. Hopefully I'm correct. 5, so since that's positive, so when x is equal to -4, the gradient at that point is 5. That's a positive gradient. So we know the function is increasing before it reaches our maximum. And if you want to be sure, you might want to do f of -2, which equals -2 squared plus 2 plus 2 times -2 minus 3. We get 4 minus 4 minus 3. So we get -3 So the gradient when x is equal to negative 2 is negative 3. So the function is increasing before and decreasing after. So we can say when x is equal to 3, that is our maximum, or local, I'll write local maximum. Local maximum as the function is increasing before and decreasing after. So we've determined our maximum. Now you want to go determine your minimum. Now what you could do is, since you found your maximum, you can just say, okay, well, therefore when x is equal to 1, that will be my minimum. But if you really want to be sure, you could do the test again. You know what I've done? I've done a little mistake. I forgot to put that dash there. Sorry. F dash is 0. So we've got 0 squared plus 2 times 0 minus 3. So therefore we get negative 3. And the other point was f dash of 2. So we get 2 squared plus 2 times 2 minus 3. That's 4 plus 4 minus 3. So we get a gradient of positive 5. So again, you can go and say when x is equal to 1, the function is decreasing before and increasing after. So this is our minimum. So that's our minimum turning point. All right. So that's doing a gradient test. It is a bit of a lengthy process, but it's something you can do. The last method was the second derivative test. Now the second derivative test, quite straightforward once you get the hang of it. I'm just going to draw or write up my function again, because it's always good to write it up so I remember it myself. And I'll write my gradient function again. On x squared plus 2x minus 3. Now the second derivative test is when you differentiate the gradient function again. So we'll have f double dash x. That's the second derivative of the original function. So if we differentiate the gradient function again, we'll get 2x plus 2. Alright? Now when you're doing a second derivative test, alright, it's really important you substitute in the x values of your turning point. Alright? So if I substitute in my x values for my turning point, I have f double dash of negative 3, which means 2 times negative 3 plus 2. We get negative 6 plus 2. We get negative 4. And I'll explain what this means soon. And if I do the f double dash of 1, we get 2 times 1 plus 2, which is 2 plus 2, which is 4. Now what happens is when the second derivative is less than 0, that means we have a maximum. And when the second derivative is greater than 0, that means we have a minimum. Now, in simple words, what this has done is, this over here is our original. This over here is our original function. I'll write it down. This over here is our gradient function. Right? And this is the gradient of our gradient function, or the gradient function of our gradient function. So gradient function of the gradient function, so it's pretty much the gradient of this right here. That's what it is. So this function over here determines the gradient of this function over here. And if you think about it, that forms a parabola, a positive parabola, right? Where our turning points are at 0. Okay, so when when y is 0, that determines our turning points. So what it's doing is looking at the gradient of those points and determining that. So it's a bit of a there is a proof behind it, which I won't go over, but that is the whole process. So if you just understand this over here, and you understand that the second derivative, when it's less than 0, it's a maximum, and when the second derivative is greater than 0, it's your minimum, you can use that to prove which one is your maximum turning point or your minimum turning point.